Hello and welcome to the third video in this series following along the development of Socks, a simple walking game. In this video we're going to retrieve the player's eggs from a database and save them to the database after modification. So if you remember, in the very first video we implemented this egg service that just interacts with an in-memory list of eggs. So now what we want to do is essentially what this to do here is about, i.e. read the player's eggs from the database, and also after the sort of walk method is called, we also want to save the eggs to the database. Interacting with a database in Spring Boot requires a few dependencies to be added to the build script. The first is the Spring Boot starter data JPA dependency, and JPA is a Java standard that acts as a layer of abstraction around a database. So instead of writing SQL statements directly to persist or retrieve records, you can annotate classes with the JPA annotations and essentially have JPA do the heavy lifting. So note that JPA is a specification of which there are multiple implementations that you might hear about. So some of the popular ones are Hibernate and Apache OpenJPA. And I believe that the Spring Boot starter data JPA package uses Hibernate by default. And Hibernate's an extremely popular one that if you ever get a job using Spring Boot, you'll definitely come across that when interacting with a database. The second dependency we've added is the Flyway dependency. And what Flyway is it's a database migration tool that essentially takes care of running scripts to, for example, create tables and add columns and so on when you start up the application. And it knows what migrations have been applied before and will essentially only run the migrations that have been added since the last one it ran. And the final dependency we've added here is just the Postgres driver, which is just used to connect to the database. So obviously the database we're going to be running behind the scenes is a Postgres database. There are alternatives like SQL Server and so on, and MySQL. To configure Spring Boot to connect to a database, we provide the data source details in the application.yaml file. So the details required are a URL, a username, and a password. And here what this notation means is it'll look for the DB URL environment variable, and if that's found it will use it, and if it's not found it will just default to this value here. And we're just doing that essentially for convenience, so when we're developing locally it will just default to this and we won't have to set up an environment variable. The first migration script itself, which is simply an SQL file. So in the resources, let's create a new folder called, we've already got the DB, so we'll call it DB and then migration. And then in that folder, we'll create a file with a particular file name. So the file name needs to start with a V followed by a version. I believe that this version can be anything, but I usually just go for a number so that when it's ordered alphabetically, which is just what the default sort of file viewer will do, they're shown in order. And I zero pad the version with zeros like that. So if we create that file, and then in this migration all we want to do is create an eggs table. So don't worry too much about this first line. That's just for Postgres to add this UUID extension. The actual thing that matters is we're creating a table with an ID, distance walked, total distance, and an item if the egg has one. And we also need to tell Flyway where to look to pick up these migrations. And we do that again in the application YAML file, just by creating a variable called Flyway locations, and then just the name of the file here, which matches this db/migration. So we should be in a good place to spin up our database and see the migration in action. So I've created a Docker Compose file to start an instance of Postgres. If we look at this, it starts up an instance of Postgres and also this pgadmin tool. If you're interested in learning more about this, I've created a video about using Docker to set up a local development environment and linked it in the description. But for now, since we already have this set up, all we need to do is in our terminal run docker compose up, and then also -d. And that should spin up our database and pgadmin itself. So with those containers started, we should be able to run the application itself and see the migration applied and the table be created. So here in the console, you can see one migration has successfully been applied, called the create egg table. And if we open up Postgres admin itself, we should be able to see the table itself be created. Yeah, so we've got an egg table, and we also have this Flyway schema history table, which is just Flyway's record of what has been applied, what migrations have been applied. So we see there's only one migration, and it's the one that we've just written. So while we're here, we may as well add an egg to our egg table. Just insert a value into it. Not very good SQL there. There we go. So it's successfully inserted one egg. So with the database side of things set up, we can return to the code and work on reading these eggs from the database. So this class here, the egg class, is the objects that we want to read from the database. And to identify this class as a JPA entity, we need to add the entity annotation to the class, like so, and also mark the primary key, which is ID in this case, with the ID annotation. So left to its own devices, Hibernate will usually try and create an egg table, and since we're having that all managed by Flyway, we basically want to disable Hibernate from doing that. And to do that, we just configure it to essentially not try and build any tables or anything like that. So we have our egg class all annotated up. Now we need to create a repository that ultimately will read these eggs from the database and also save them to the database. So we'll create a new class, or actually interface, called egg repository. And we will have this interface extend CRUD repository, which is just an interface itself that provides a collection of methods like save, sable, find by ID, and so on. So to use this CRUD repository, we have to pass in the entity that we're using, which is just egg, and also the type of the ID of the field, which is just UUID. So just for a bit of extra information, so the CRUD here stands for create, retrieve, update, and delete. So that's the sort of four types of function that this repository provides us. And repository itself is just the domain-driven design term that means essentially an object that abstracts away persistence. So what this all results in is basically an egg repository that has a set of methods to get eggs from the database, as well as save them and update them, and also delete them. So we also need to annotate this class with repository. And here the repository is similar to the other Spring annotations that we've seen, like service. It just tells Spring what this class is, in this case a repository. I think I'm just going to move this repository into a package of its own, because we probably will have more repositories as we go along. So let's start using this egg repository. So as mentioned earlier, in the egg service class, we were just using this fixed list of eggs, and we basically want to replace that with a call to the repository instead. So what we'll do is first request to have the egg repository itself injected. And with the egg repository, we can just call egg repository dot find all, which unfortunately returns an iterable instead of a list. So we just have to add a little bit of code to convert it into a list. And in this case, we just use this stream support class to essentially convert the iterable into a stream and then collect as a list over here, thus converting it to a list. So similarly, we want the walk method to change a little bit so that it gets the eggs from the get egg method, and then later on saves them down here. So we use the sable method. So we should be able to restart the application and make some calls to the API to get the eggs directly from the database. So that's started up. So it looks like it's failing due to not having a default constructor on our entity. So if we go back over to the egg class, we can just add a constructor that takes in no variables. And unfortunately, we have to change all of these to be non-final. And now if we restart our application, hopefully it'll all be all right. There we go. And we're getting our eggs out as expected directly from the database. And we should also be able to walk the eggs a little bit. Yeah, so we see that this has walked 1.5 kilometers. And if we then go back to calling our get eggs, we should see that this has changed. So it's all being persisted to the database as expected. So we've made some fairly substantial changes to our application. So I'd expect to find that all of our tests no longer pass. So let's see what happens when we run them. So let's take a look at the egg controller test first. Okay, so it looks like the reason this test is failing is because in the unit test it's trying to do the Flyway migration. And the reason it's doing that is because we've got this class annotated with Spring Boot tests. So it's essentially trying to spin up a test version of our entire application. So what we want to do to stop it from doing that is essentially disable the data source auto configuration part of the application. And to do that, we just do this enable auto configuration annotation and then just tell it to exclude the data source annotation configuration. Now if we run that, I'm expecting this to just work fine. Great. So that's good. So I think our other one, the egg service might be a bit trickier to solve. Let's just run this again. So the egg service tests are all failing because instead of using a fixed list of eggs, it's retrieving them from the egg repository. And at the moment, we're just passing in null here. So what we need to do is provide a version of the egg repository that returns essentially the same eggs as we previously did with our fixed list of eggs scenario. So to do that, we can use the mocking framework Mockito, which is a very popular framework for essentially creating mocks of classes. And to use that, we just use the extend with annotation on our test class and pass in the Mockito extension. And then what we can do is add a egg repository field to our class and annotate it with the mock annotation. And essentially what this will do is the Mockito extension will pick up this mock here or identify this as a class that we want to mock because of the mock annotation, and then set up a mock for us, which essentially just avoids a bit of boilerplate code. So we'll set up the behavior of this mocked egg repository in a setup method, which is run before every single test. And what we'll do is just using the Mockito when function, we'll make it so that whenever the find all method is called on our egg repository, then it returns some fixed list of eggs. And the fixed list of eggs, we just grab what we commented out over here and just pass back and just use that list. And now we can change this slightly so that we move the creating of the egg service into the setup function and just pass in our mocked version of the egg repository there and just get rid of that. So now I'm expecting the get eggs test to pass, but let's see what happens. Cool, so that now works as expected because we've mocked the egg repository to return exactly the same as what was previously being returned from the fixed list version of egg service. So the walked test is a little bit more complicated as we're saving the eggs to the database. So we essentially want to verify that the save all method was called on the egg repository. And to do that, we can use Mockito's verify method. So what we can do is after this walk method has been called, we can actually scrap that. After this walk method has been called, we can use the verify method from Mockito to confirm that essentially this save all method was called at least one time, a single time, and the arguments passed in were just any arguments. And if we just we comment that out, we should get the test to pass. That's good. So this is a good start. However, it doesn't actually check what was saved to the repository. So instead of just checking whether there was anything at all, we can use a captor to capture what was being passed in and check its value. So we set up a captor like so. So up here we add an argument captor, and what we're expecting to capture is a list of eggs, and we just annotate it with captor. So sort of similar to mock, it will just mean that our Mockito extension sets this up for us. And now we can go back to our verify method, our verified call, and pass in the eggs captor dot capture to essentially get the value of what was passed into this save all method. So now we can read the value, which is just some eggs, from our captor, eggs captor dot get value. And then we can uncomment this line down here, so it will now carry on to check what was saved to the database. And with any luck, that will still pass with a more thorough test as well. Brilliant. Cool. So yeah, so in this video, we've set up the Flyway migrations as well as implemented essentially saving eggs to the database and retrieving them from the database. In the next video, we're going to go back to the Flutter app and implement some state management using the block pattern. Yeah, any suggestions or questions are welcome in the comments. Thanks for watching.